Amphipoda is an order of malacostracan crustaceans with no carapace and generally with laterally compressed bodies. Amphipods range in size from 1 to 340 millimeters, 0.039 to 13 inches, and are mostly detritivores or scavengers. There are more than 9,900 amphipod species so far described. They are mostly marine animals, but are found in almost all aquatic environments. Some 1,900 species live in fresh water, and the order also includes terrestrial animals and sandhoppers such as Talatris saltator. The name Amphipoda comes, via the New Latin Amphipoda, from the Greek roots mu phi, different, and by omicron sigma, foot, in reference to two kinds of legs that amphipods possess. This contrasts with the related Isopoda, which have a single kind of thoracic leg. Particularly among anglers, amphipods are known as freshwater shrimp, scuds or side swimmers. The body of an amphipod is divided into 13 segments, which can be grouped into a head, a thorax and an abdomen. The head is fused to the thorax, and bears two pairs of antennae and one pair of sessile compound eyes. It also carries the mouth parts, but these are mostly concealed. The thorax and abdomen are usually quite distinct and bear different kinds of legs. They are typically laterally compressed, and there is no carapace. The thorax bears 8 pairs of underlimous appendages, the first of which are used as accessory mouth parts, the next 4 pairs are directed forwards, and the last 3 pairs are directed backwards. Gills are present on the thoracic segments, and there is an open circulatory system with a heart, using hemocyanin to carry oxygen in the hemolymph to the tissues. The uptake and excretion of salts is controlled by special glands on the antennae. The abdomen is divided into 2 parts, the pleosome which bears swimming legs, and the urosome, which comprises a telson and 3 pairs of uropods which do not form a tail fin as they do in animals such as true shrimp. Amphipods are typically less than 10 millimeters, 0.4 inches, long, but the largest recorded living amphipods were 28 centimeters, 11 inches, long, and were photographed at a depth of 5,300 meters, 17,400 feet, in the Pacific Ocean. Samples from the Atlantic Ocean with a reconstructed length of 34 centimeters, 13 inches, have been assigned to the same species, Lice giganta. The smallest known amphipods are less than 1 millimeter, 0.04 inches, long. The size of amphipods is limited by the availability of dissolved oxygen, such that the amphipods in Lake Titicaca at an altitude of 3,800 meters, 12,500 feet, can only grow up to 22 millimeters, 0.87 inches, compared to lengths of 90 millimeters, 3.5 inches, in Lake Baikal at 455 meters, 1,500 feet. Mature females bear a marsupium, or brood pouch, which holds her eggs while they are fertilized, and until the young are ready to hatch. As a female ages, she produces more eggs in each brood. Mortality is around 25 to 50% for the eggs. There are no larval stages, the eggs hatch directly into a juvenile form, and sexual maturity is generally reached after 6 molts. Some species have been known to eat their own exuvi after molting. Over 9,950 species of amphipods are currently recognized. 12. Traditionally they were placed in the 4 suborders Gammaridea, which contain the majority of taxa, including all the freshwater and terrestrial species 7, Coprolidea, Hyperidea, and Ingolphiolidea, the latter with only 40 species 13. The classification of the Amphipoda is however being rearranged to better reflect their phylogeny, the relationships within the suborder Gammaridea having suffered from the most confusion. A new classification has been developed in the works of Lowry and Myers, where a new large suborder Syntacaudata was split off from the Gammaridea in 2013. That taxon, which also encompasses the previous Coprolidea, now comprises over half of the known amphipod species. The classification given below, from the rank of suborder down to superfamily, however still represents the traditional division as given in Martin and Davis, 2001, except that superfamilies are recognized here according to some people within the Gammaridea. Amphipods are thought to have originated in the lower Carboniferous. Despite the group's age, however, the fossil record of the order Amphipoda is meager, comprising specimens of 12 species dating back only as far as the Upper Eocene, where they have been found in Baltic Ember. Amphipods are found in almost all aquatic environments, from freshwater to water with twice the salinity of seawater. They are almost always an important component of aquatic ecosystems, often acting as mesograzers. Most species in the suborder Gammaridea are epipenthic, although they are often collected in plankton samples. Members of the Hyprantia are all planktonic and marine. Many are symbionts of gelatinous animals, including salps, Negiaceae, siphonophores, colonioradiolarians and ctenophores, and most hyprids are associated with gelatinous animals during some part of their life cycle. Some 1,900 species, or 20% of the total amphipod diversity, live in freshwater or other non-marine waters. Notably rich endemic amphipod faunas are found in the ancient Lake Baikal waters of the Caspian Sea basin. The landhoppers of the family Laterally, which also includes semi-terrestrial and marine animals, are terrestrial, living in damp environments such as leaf litter. Landhoppers have a wide distribution in areas that were formerly part of Gondwanaland, but have colonized parts of Europe and North America in recent times. Around 750 species in 160 genera and 30 families are troglodytic, and are found in almost all suitable habitats, but with their centers of diversity in the Mediterranean basin, southeastern North America and the Caribbean. In populations found in benthic ecosystems, amphipods play an essential role in controlling brown algae growth. The mesograzer behavior of amphipods greatly contributes to the suppression of brown algal dominance in the absence of amphipod predators. Amphipods display a strong preference for brown algae in benthic ecosystems, but due to removal of mesograzers by predators such as fish, brown algae is able to dominate these communities over green and red algae species. Compared to other crustacean groups, such as the Amphipoda, Rhizocephala or Copepoda, relatively few amphipods are parasitic on other animals. The most notable example of parasitic amphipods are the whale lice, family Siamidae. Unlike other amphipods, these are dorso-ventrally flattened, and have large, strong claws, with which they attach themselves to baleen whales. They are the only parasitic crustaceans which cannot swim during any part of their life cycle. Most amphipods are detritivores or scavengers, with some being grazers of algae, omnivores or predators of small insects and crustaceans. Food is grasped with the front two pairs of legs, which are armed with large claws. More mobile species of amphipods eat higher quantities of less nutritious food rather than actively seeking more nutritious food. This is a type of compensatory feeding. This behavior may have evolved to minimize predation risk when searching for other foods. Amphipolongimana, for example, is more sedentary than other species and have been observed to remain on host plants longer. In fact, when presented with both high and low nutrition food options, the sedentary species Amphipolongimana does not distinguish between the two options. Other amphipod species, such as Gammarus mucronatus and Elasmopus levis, which have superior predator avoidance and are more mobile, are better able to pursue different food sources. In species without the compensatory feeding ability, survivorship, fertility, and growth can be strongly negatively affected in the absence of high-quality food. Compensatory feeding may also explain the year-round presence of Aulongimana in certain waters. Because algal presence changes throughout the year in certain communities, the evolution of flexible feeding techniques such as compensatory feeding may have been beneficial to survival. Amphipolongimana has been observed to avoid certain compounds when foraging for food. In response to this avoidance, species of seaweed such as Dicteturus membranacea or Dicteturus hoytii have evolved to produce C11 sulfur compounds and C9 oxo acids in their bodies as defense mechanisms that specifically deter amphipods instead of deterrence to consumption by other predators. The incidence of cannibalism and intra-adult predation is relatively high in some species, although adults may decrease cannibalistic behavior directed at juveniles when they are likely to encounter their own offspring. In addition to age, the gender seems to affect cannibalistic behavior as males cannibalize newly molted females less than males. They have, rarely, been identified as feeding on humans. In Melbourne in 2017, a boy who stood in the sea for about half an hour had severe bleeding from wounds on his legs that did not coagulate easily. This was found to have been caused by sea fleas identified as Lice-acid amphipods, possibly in a feeding group. Their bites are not venomous and do not cause lasting damage. Everyone loves amphipods.